Hello, people. Yes, welcome to Smart Physics. And today we are here to explain measurement in physics. We all know that the beginning of physics starts with measurement. So I'll brief on explaining the topic measurement. This will help us to continue with all subsequent topics on vectors, forces, pressure, and all this. So with measurement, we will first take it from the 7 base quantities and then their SI units, okay? And then we remember we talked about length measured in meters. We talked about mass in kilogram. We talked about time in seconds. Temperature in Kelvin, amount of substance in moles. We also talked about luminous intensity in candle. And then we also have a measure. These are the 6 base, and yeah, you can think of any other one to add the 6 base quantities. The most important part is that we are not supposed to forget about their SI unit. This is because scientists then believe that we all have to speak the same language, okay? So if you are in China, you are in Germany, you are in France, or wherever you are, and you are taking measurements of length, okay? You said we measure it in meters. You can choose to measure it in inches, in feet, and what have you. But then scientists came together and then go with only one measure, that if you have a measure in feet, you should convert it to meters. If you have a measure in inches, you should convert it to meters and all that. The symbol for meters is what? We use a small m to represent that. That's of kilogram, we say kg. Most students often do not forget that kilogram is used for physics, okay? So if you're a scientist, being in the chemistry lab or the biology lab, you normally use gram, okay? But for physics, we look at what? Big objects, right? So we measure mass in kilogram. We also talk about time in what? Second. Temperature in Kelvin. So same thing applies to this. People measure it in degrees Celsius and then Fahrenheit and all those. You know how to convert it to Kelvin. We also talked about amount of substance, and that's measured in mole. The unit is mole, okay? And then the luminous intensity can be written as C and then a small e. Okay, so this is basically what measurement is all about. We should basically understand this, and then it will take us to our next topic, vectors and then scalars. Another thing is that after these measures, they then think of it that some of them, when you measure, you have to take into consideration the direction. Okay, so when you measure some quantity, you have to take into consideration the direction. The direction affects the measure, and also some of them, when you take the measure, the direction do not affect them. Scientists then think of it that, okay, so the ones that the direction really affect the measure, as we want, vector quantities. So, for instance, from this quantity, we can derive other ones, and we call them derived units or derived quantities, right? So some like pressure, we know that pressure P is equal to force over area. Force is also a derived quantity. Force is equal to mass times acceleration. Okay. So you can see over here that we are getting mass, which is a base quantity. Okay, multiplying acceleration. Acceleration is a change in velocity with respect to time. And you can see that in the acceleration, we are having some base quantity time in there, but we have another derived quantity, u, velocity. Velocity u is what? How fast an object is traveling, and that is what? Distance over time. So we've gone down to the extent that we are getting our base quantity, distance and time. And distance is length, which is measured in meters. Time is measured in seconds. That is giving us what? The u, our velocity. And that's a change of it with respect to time is going to give us acceleration. When we multiply acceleration by mass, we are getting force. And when we divide that force with area, we are getting pressure. So this is how we derive another quantities from base quantities. And that is what? Derived quantities. Are we okay? Now, among these derived quantities and base quantities, we group them into what? Two. Okay? Depending on the measure. Some of them, when we measure, we have to take into consideration the direction. Okay? So the ones that we measure the magnitude and the direction, we call them what? Vectors. For instance, force. Okay? How do we define force to be? We said force is a pull or what? A push of an object, right? So we take into consideration where the applied force is. Okay? When you pull, the direction is towards you, and when you push it, the direction is towards the objects. Are we good? So force is what? A vector quantity, because we can measure the magnitude. It can be some 20 Newton, 50 Newton, 100 Newton, and then we take into consideration the direction. Okay, so in physics, something like this, when I push a box with a force of 20 Newton towards the right side, we said it is a positive 20 Newton. Okay, that same magnitude can be pulled, and when we pull it, we get a negative 20 Newton. So that's basically what force is. Okay, so this is a typical measure, and this measure depends on both the magnitude and the direction. Very good. So that is vectors. Another one that we call scalars are those that when we measure, we normally don't take into consideration the direction. And those ones, for instance, time. Okay, we don't take into consideration the direction. You can stay anywhere. If it's 2 p.m., it's 2 p.m. everywhere. Is that right? Okay, so that is basically what we have here. In our next video, we will talk much about scalar quantities and the vector quantities. See you.